Thank you for coming to this session. My name is Ray. I'm a developer advocate for Google Cloud Platform. And one of the things I love to do is to bring some of our best technologies to developers all over the world, especially Java developers, because I've been a Java developer for a long time. It's my go-to language of choice. And yeah, it's also a great and vibrant community. And I love to bring some of the things that we have to show you. Another thing I like to do, because of this, is I like to make sure that we have really good experiences for Java developers to use Google Cloud Platform. And so I work with a lot of the teams internally, like for Cloud Functions, for App Engine, for Cloud Run and stuff like that, to make sure that we have a pretty good, awesome experience there, as well as the API services and stuff like that. And because of that, I also help introduce and kick-started a project called Spring Cloud GCP. And it is an idiomatic approach to help you to bootstrap your Spring application and consume some of the Google Cloud services very idiomatically and easily. If you have any questions, any feedback, please let me know on Twitter at Satanism. Or if you want to see and find more information, you can go to my site, which is satanism.me. And I only have about 4 slides for this session. And we are about 75% through. And let me show you the last slide. And thank you for being here. Just kidding. So I'm just going to jump into it and just show you what we can do as from an experience in developing for GCP perspective for a Java developer. Okay? So one of the projects I mentioned was Spring Cloud GCP. Now, I just want to see a show of hands. How many people here are Java developers using Java language, JVM languages? Yeah, everyone? Good. You're in the right room. So am I. How many of you are using Spring and Spring Boot? Majority of you. Yeah, that's what I expect. And if you haven't checked this out, please do. We basically wanted to make sure that from a Spring developer perspective, you can use some of the Spring abstractions and Spring layers that you're accustomed to and being able to use some of our APIs and services. Now, the reason for it is a couple-fold. Number one is that it's going to be a lot easier for you to get started, right? So you know your framework, you know how to use those things, and you can just change out some implementations, add some starters, add some auto configuration, and you're right into the Google Cloud services. The other part of it is that if you have an existing application that you want to migrate, right, there are some different approaches. One of them is maybe that you want to just migrate the VM, so you put a VM into Google Cloud, and now you're still using the traditional databases and stuff like that. But if you want to change and gain some velocity and being able to adopt some of the services, you have 2 choices. Right? You either use the API, which then you're tightly coupled to the API itself, or you have some kind of abstraction layer that you can be a little bit more portable so that if you want to change out the implementation in the future, you also can. Right? So check this project out. So we have integration for like Spanner and data store with Spring Data. So you can use basic ORM and data repositories to access data. We have logging and tracing integrations directly into the Spring framework as well, and PubSub and much more. Okay? I'm going to show you some of these things today, but most importantly, after we bootstrap an application, we're going to containerize it, we're going to deploy into Kubernetes, and we're going to go through some of the best practices or things that you have to watch out for when you are actually deploying applications into a Kubernetes environment. Okay? So without further ado, I'm going to get started. I have no backup for this. It's going to be a straight shot from nothing to something. I hope that works. So it's either going to be OK or it's going to be horribly wrong. OK, so let's go. So for this demo, what I'm going to do is to just go to start.spring.io to bootstrap my new project. I'm going to use Kotlin for this because for Java, for JVM, you can run any JVM languages on Google Cloud, of course. So with App Engine, you can do the JVM stuff. You can do Kotlin, Groovy, Scala, or just Java language itself. I'm going to make a jar packaging here, and I'm going to use Java 8. And of course, in this bootstrapping, you can also add different capabilities to your application. Now, the important thing here that I'm adding here is the GCP support. So by adding this, we're going to pull in some of the auto configurations into my project, and that's going to make my application work with some of the Google Cloud services. Okay? So I'm going to go ahead and download this. I'm going to unpack it and open this up in my IntelliJ plugin here and IDE, and we'll see what happens next. Yeah, and where's my IntelliJ? That's oh, there it is. You went to the wrong window. That's weird. OK, so let me just synchronize this project a little bit, just make sure that this is actually the application we just created. OK, and let me just go ahead and go to the presentation mode too. So I think I can enter presentation mode. So you can hopefully see all the code a lot easier. So we have a application here that has nothing, of course. It's going to start up and listen on port 8080, and that's pretty much it. So the first thing I'm going to do is to add some capability to store data. Now, we have, of course, many different ways for you to store data. We have Cloud SQL for you to do RDBMS with MySQL or Postgres. We have Cloud Spanner, which is a globally distributed database for RDBMS as well. Or we can also use data store, which is a NoSQL data store that's document-oriented. You don't need schemas. You can just say, I need data store, and just start putting data into it. So for this demo, I'm just going to use the data store stuff, right? So the easiest thing for me to do is to add the starter for Cloud Data Store. So we have a shortcut here for the dependency. And what this will pull in is Spring Data and a few other components, and also add the data store abstraction layer on top of this. What that means is that you can actually go ahead and create a new POJO, and you can annotate it just like you do with the traditional database with JPA. It's going to be very similar here. So what I'm going to do is just to create a new class here called person. I'm using Kotlin here, so rather than using all the getters and setters, I can just create a data class here, and it's going to have two attributes. It's going to have an ID, which I'm going to change the type to long, because in data store we can auto-generate the ID for you, and we can go ahead and just mark it as an ID. Now notice how the ID annotation is here. This is actually the regular Spring annotation for a primary key. And for the data class here, we can just go ahead and make an entity. And this entity is special for data store. This marks it as a data store entity, so we know how to map it to our backend services. Okay? And then we can use the Spring Data repositories for CRUD access and also pagination. What that means is that I can create a new interface here. I can call it person repository. And I can go ahead and extend the interface here called data store repository, this one. And I can just give it a domain type, which is going to be person, and the ID type, which is going to be long, and that's it. That's all you need to do. And you can start using this repository. Spring and our frameworks will automatically implement this interface for you, so you can go ahead and use it to store data. We're going to go a little bit further. We're going to use the Spring Data REST annotation here, which means that we can actually expose this entire repository as a RESTful service. So just like that, you get CRUD access to the data store entity called person, and we should be able to store data and read data from it. Okay? How many people think this would just work? Wow, nobody. Thanks. So why don't we just go ahead and run it? I'm going to use my touch bar. There's a little run button there, which is really handy. And we can actually see and hopefully run this application. Yeah, and it just started off in 2.7 seconds. That's, I don't know. Whenever my Java application starts really quickly, I don't know if it's going to work. So we're going to find out pretty soon, OK? And I'm going to go ahead and use my IntelliJ IDE here. I'm going to go ahead and create a new, where did it go? Oh, yeah. Oh, no. The screen is too small, so I'll have to scroll down a little bit. A new HTTP request. I'm going to call it test. So rather than use curl, I can actually just go to my IDE and maybe do something like this, right? So get tr, maybe that one. So I'm going to go to my localhost 8080, and then I'm going to see if my endpoint is up and running. And let me go ahead and run it. And whew, it actually works. So I just hit my local RESTful service. I went to the person's endpoint that was automatically generated by Spring Data. And I can see that I have no data entry in this service. OK? Pretty cool. So why don't we go ahead and just post some data into it. So I'm going to just write a little snippet here. I'm going to post to 8080. I'm going to post it to the person's endpoint. And for the data here, I'm going to, let's see here. We have a field called name. And I'm going to say Ray in here. That's my name, by the way. So let's go ahead and run this post, and we will see what happens. So I'm posting to this service that I just created in about 3 minutes. And we can already see it saved the data. And we also got a primary URL here with a primary key that we can call. So we can just go ahead and say, well, let's go ahead and get this as well and see what is the data inside. And we can see the data record here. And of course, if I go back to persons, I should be able to see now we have one entry. Now notice also we have pagination here, so that's really, really handy. Now, if I want to go back to the console, what I can do is to go to the data store console here within my project. So I'm going to go find data store. Because some people might say, wait a second, is that real? Did that just happen? The only way I can prove this to you that this actually works is now you can actually see that we actually have a data entry there, right? But of course, this data entry could have been there this whole time. You will never know. So what I'm going to do is I'm going to go back to my application. I'm going to do just bootstrap a little bit more functionality here. Okay. So I'm going to go ahead and create a hello world controller here. Whoa. Let me just make sure. Yeah, I'm going to say hello. And it's going to be a REST controller. And I'm going to map a URL here called the /hello. I'm going to pass in a name here for the name string. I'm going to log it. I'm going to return hello back to whoever that said hello to me. And I'm just going to go ahead and use private val here to inject the person repository that I just created now. And what I'm going to do is, in addition to saying hello back, I'm going to use the person repository and save the data back into this, right? So I'm going to say name is equal to name and something like that, okay? And hopefully that will just work. Oh, by the way, to simulate that we have multiple services to call each other, because you usually don't have just one service. I don't have time to create 2 of them today. But what I'm going to do is to just simulate this whole thing by making another endpoint that's going to call a few names here. I'm going to call Mike, who's the TL on the Spring Cloud GCP project. Mandy, who is one of my colleagues that I first worked with when I joined Cloud. Jisha, who was also awesome. She contributed a lot to this project. I'm going to say hello to each of the names. I'm going to use the REST template client to make a call to myself to say hello so we can simulate calling another service, right? Just because I don't have time to write 2 of them. And so to do this, I need to go ahead and, of course, go ahead and just make sure we have a REST template bin that we can bootstrap, right? All of these are pretty idiomatic to Spring. And I need to go ahead and automatically inject this into my controller as well. So I'm going to go ahead and do a private val REST template and just inject it here. So now I have 2 more endpoints. I have /hello, which I will save the data. I'm going to say hello all, which will say hello to 3 people, and it will save each of the data as well. And I'm going to go ahead and just restart this application. I hope that's going to just work as well. So I'm going to stop and run. Whew. And let me see, just make sure this is actually rebooting. Yeah, very good. And I'm going to go back to the test HTTP here, and let's just do a few more things. Okay, that also started pretty quickly, so hopefully this works. So I'm going to say hello to localhost 8080 /hello. I'm going to say name is next. Let's do that. And let's run it. Say hello to next. And of course, we get a hello back, right? And remember, we also save the data. And just to show you that this is actually saving the data now, right? We can see this up on the screen in the data store, right? And I can also say hello to all. So rather than saying hello to just one person, I'm going to say hello to all, right? So it's going to iterate through and say hello to 3 different people, right? And if we go back to the log, we should be able to see that we say hello to Mike, Mandy, and Jisha. And if we go back to the data store, we should be able to see all of the people I said hello to, right? So it's very rapid that you can develop your application very quickly now. So what's next? In a microservices application architecture, if you do have all of these services calling each other, A equals B equals C, you kind of need some way to observe and kind of understand what is the code stack across all of your services. And to do that, you may need to add some distributed tracing capabilities. And there are a number of libraries out there you can use, like Open Tracing, Open Senses, and Brave, and so on and so on. In Spring, we have Spring Cloud Sleuth, which can actually add distributed tracing capability to your app. Now, regardless of whether you deploy your application into a Istio environment, which can trace things for you, regardless of whether you do that or you just deploy it in plain Kubernetes or VMs, you always need to propagate the trace ID. You always have to do that. And Spring Cloud Sleuth or some of these tracing libraries can capture the trace ID for you and propagate it for you automatically. Now, for our demo, what we're going to do is go even a step further by adding a tracing starter here that we created for Spring Cloud GCP. What this will do is to build on top of Spring Cloud Sleuth, which is built on top of Brave. What this will do is to automatically capture the trace IDs. If not, it's going to generate one for you. And it's also going to automatically propagate it downstream to the next service code when you're using REST template. And we're also going to automatically propagate all the traces into Stackdriver trace. Okay? And we just done that by adding the starter. We don't have to add any other additional code. The only other thing I may actually add is the probability of a trace to be stored. By default, we only capture 10% of the traces, or the request, we're going to store the trace. For the demo, I'm going to up it to 1.0, which is 100%, so we can actually see everything that's coming through. Now, in addition to doing this, what I also want to do is to log my messages into Stackdriver as well. So we have a logging starter for that. What this will do is to allow you to add log back configuration fairly easily, and you can then bootstrap your application that will understand how to log into Stackdriver logging. And there's a reason why I'm doing this, which I'll show you in a second. Okay? So let me just go ahead and do this one. I'm going to use this template for now. So what this will do is to log the message to the console so I can see it in std out. But I'm also going to log it to Stackdriver as via the API. So now we have two log appenders. It's going to split the log message, and we're going to simultaneously send it to both places. Okay? So let me go ahead and just restart this app and see if this is all hooked up properly. And hopefully, we'll get to see the traces and the log messages. And if you've seen so far, there's not so much code, right? Because Spring and Spring Boot, the framework itself, is doing a lot of the work behind the scenes for you. Okay? So it's all started. So let's go ahead and go back to my test. I'm going to say hello to O. Now, ideally, what happened here is that I triggered this request. The trace ID is generated. It's propagated downstream via the REST template to the next call. We have 3 calls, so all of them are correlated together. If I actually go back to the run, if I look at the log, now not only do we see the names, if I scroll left a little bit, we can confirm that here's a trace ID that spans across 3 different calls, and each of the call is a span. It has a span ID, and they're all being sampled, meaning that they are all being stored into Stackdriver trace. Okay? So what that means is that if I go here and go to trace and see the trace list, I have this one additional entry that maybe just came in. Yeah, there it is. And we can see that we call localhost 8080/all. We can see the 3 different REST template calls to the remote services, which is myself. And we can see how long each of those take, right? And furthermore, because we appended the log, we send the log to Stackdriver logging along with the trace ID and the span ID, we can actually do this, which is show you correlated logging. So because all of these ID tie up, I can actually go and see, OK, what happened in this span? What kind of error messages came out of it? They're all correlated together, which is really, really useful if you're actually trying to debug some of the production environment issues. OK? So that's pretty much it for my service for now. What do we do next? Okay, let's go ahead and deploy it into my Kubernetes cluster in this case. Now we have, of course, many, many ways to deploy this. We can deploy this into App Engine as a jar in the new App Engine runtime. We can deploy this into Cloud Run as a container. We can deploy this into Kubernetes, whether it has Istio or not. It doesn't really matter, right? So we're just going to take the long route of, let's deploy this everything into Kubernetes, and I'll show you all the intrinsic details that we have to care about when we are running a Java application inside of a container. Okay. So what we're going to do first is to containerize. So we're going to talk a little bit here about containerizing. Can I not spell today? Containerize. There we go. And then we're going to talk about a little bit about the liveness checks and readiness checks. And we need to talk about how do you listen to the graceful shutdown events that is a contract with the Kubernetes runtime, or in any Docker environments that you actually have an orchestration tool. You want to be able to shut down gracefully. And then finally, we're going to look at monitoring as well. How do you export metrics from this particular application so that we can see it from Prometheus dashboards in this setting. And if we have time, we're going to see how we can actually debug this application in production environment, in a Kubernetes environment as well. Okay? So we're going to get through that, hopefully, in the next 30 minutes or so. So let's get started. Now, when you're containerizing this application, you have to be very careful. I don't know if anyone here ran into this issue where you containerize a Java application, you're running in your Kubernetes cluster or some kind of environment, and then you get this weird message called out of memory killed, OOM killed, right? A lot of people run into this issue. That is mostly because the JVM runtime may or may not understand how much resource you actually assigned to your container. Okay? And to take care of this, you actually have to understand which Java version, which OpenJDK version you're using, and what type of containerized support does it actually have. Because often enough, what happens is that the OpenJDK runtime does not actually know how much memory is being assigned to your container, and the JVM will just use up as much memory as possible, and ultimately you're just going to get OOM killed, and your application will just be restarting all the time. Okay, so first we need to go ahead and containerize this application. Now, I can write a Docker file. I can write a very simple one, But I actually have a separate talk in the past, just for a whole hour, on how to write a proper Docker file that will containerize your Java app, right? There's a lot of details we have to go through. Now, luckily enough, we do actually now have a plugin called Jib. So if you're not using Jib already, please take a look. This is a Maven or Gradle plugin. You can just add it to your build file. And from here on out, I can just use it to build my container. I don't need to write a Docker file. You'll actually follow some of the best practices. And you don't even need Docker installed on your local machine. It will just push the image directly to the remote registry, right? So I'm going to go ahead and create a new image here called GCRIO. I'm going to add my private registry on Google Cloud right now. So I'm going to use GCRIO YSQLD 827. I'm going to push it to the image name called Jib demo for now. And then I'm going to remember about the JDK. We need to be very careful about what JDK version that we want to use and how do you configure that. So for me, what I'm going to do here is by using adopt OpenJDK, which has one of the newest versions of OpenJDK 8 that actually has the containerization support. You want to use something that is 8 update 1.1 or higher in order for this to work properly, to have less issues, right? So I'm going to add adopt OpenJDK, and going to do OpenJDK 8, and use the slim image here instead, OK? And that's all I need to do. And if I need to, here I'm going to go open up the console, the terminal. And I'm going to go ahead and compile this app and turn this into a container image. OK, so I'm going to do Maven wrapper here, compile, and Jib build. OK, so I first need to compile my app, of course, and produce the classes. And then Jib is going to do something intelligent. It's going to look at your Maven build file. It's going to figure out what the dependencies are. And it's going to automatically decide how to layer your Docker layers so that the dependencies goes into its own layer and your app goes to a separate layer. What that means is that when you're changing an app a little bit, you're changing a class, it doesn't have to rebuild the entire image. It just rebuilds the layer and pushes out for you automatically. And we already push it to my remote registry, and this is ready to be used. I actually hope this works, because that was also a little bit too fast. So I'm going to do a Docker pull, because this is in a remote registry. So we can pull this down, and ideally, we should be able to run it. OK? So I'm going to do docker run ti rm and the name of the image. And this should just spin up my application, and hopefully everything is OK. Yeah. Ooh, that's no good. No, that's kind of expected. That's fine. We'll fix it later. All right. So the container runs. That's good. Now you have the option to put this into Cloud Run. It should just start up. Just make sure you have enough memory for it. What I'm going to do is to just write this and deploy this into Kubernetes, right? And then continue my development cycle in a Kubernetes cluster. The way I'm going to do it is to first, I need to create a new directory where I'm going to store my deployment manifest. With Kubernetes, you do write a lot of these YAML files and manifests to define how you want to deploy something. So I'm going to do a shortcut here. I'm going to do kubectl run my, I'm going to call it demo service. And the image is the one that I just created. Yeah, there we go. And I'm going to use this flag called dry run. So what this will do is naturally not run inside of Kubernetes, but it's going to just simulate it. I'm going to see what the request is going to be in the YAML format. And I'm going to output it into my KS directory. I'm going to call it deployment.yaml. So this is a very quick way for us to kind of bootstrap a deployment file without having to write the whole thing manually. Now, there's one thing you do have to figure out here is to get rid of the beta 1 version, because it's actually GA now. So we have E1. And you can see how it just generated the rest of the files for me, right? It's pretty cool. Now we know that we have a container that will work in a containerized environment. We have to deal with Kubernetes and the Kubernetes contracts in terms of how this application will behave in the lifecycle. What that means is when the application starts, there's a liveness check that might go off. We need to be able to check whether the application is still alive, right? If the application is not responding to the liveness check, Kubernetes will have to restart it and automatically try to fix this issue. The other thing that we have to watch out for is the readiness check, right? In Kubernetes, we have 2 checks. Liveness check just determines whether Kubernetes needs to kill this instance and restart or not. The readiness check is the one that determines whether the traffic will be flowing through to my container, to my pod, right? So it's ideal to have both checks, OK? You definitely should have both. Now, the readiness check is really useful in 2 ways. One is that your application could be alive, but it may not be ready to serve, Why? Because you might need to warm up the cache. You have to make sure all the connections are established, right? Everything's ready to go before you flip the readiness check over and say, give me some traffic. The other use case of it is that when you are shutting down the application, when Kubernetes is trying to shut down your Java application, it's going to send you a SIG-term signal. It's a termination signal. And you're supposed to catch it and then do a graceful shutdown. During this whole process, ideally, you should turn off the readiness check so that you tell Kubernetes, I got the message. I'm going to shut down. Please don't send me any more traffic, right? And you use that to tell Kubernetes whether you are going to receive traffic or not. And once you have gracefully shut down and serve all the in-flight requests, you shut down your application, and everything's fine. Okay, so we're going to do both of them right now. For the liveness check, the easiest way to do that is just by adding a simple handler here that will just respond OK all the time, right? So I'm going to say, am I alive? I'm going to say OK. And I'm going to map it to maybe /alive. OK, that's really easily done. So I just added a liveness check here. The other thing that we may want to add is the readiness check. The way that I think is a pretty awesome thing to do within the Spring ecosystem is actually by using something called the actuator. So Spring has something called the Spring actuator that will expose a health checkpoint for you. So I'm going to go ahead and add the actuator right here. It's going to expose a /actuator endpoint with a health endpoint there that you can actually plug in, and you can use that to kind of flip yes or no between whether your application is ready or not. Okay? And then there are many different ways for you to do a graceful shutdown. The gist here is that you have to listen for the termination signal. In Java, the way you do it is by listening to runtime shutdown events, and then you have a separate thread that can react to it, and then that's where you respond to and shut down your application. There's actually a really nice module out there that can be useful for you. It's a graceful shutdown artifact from SBB-CH here. What that is going to do is to allow you to replace how you start your application. So rather than using the Spring Boot standard application, I'm going to go ahead and use graceful shutdown. Let me see here, Spring application, like that. Yep. And run. And the demo service application, class.java, and then all the arguments from the command line, and that's pretty much it. Okay. And so this will configure this particular module will configure your application for graceful shutdown. And of course, you can do it however other ways that you want. But the important thing here is that you have something like that. Okay. Now I'm ready to redeploy this app again. I kind of want to try this one out where I'm developing my application. I'm still adding some features to it. I need to test things out in a Kubernetes node or a cluster. But I don't want to do the git build all the time. I don't want to do the kubectl apply all the time. One of the really cool tool that you can use is called Scaffold. If you haven't tried it out, this is what it looks like. You can create a new file called scaffold.yaml, add it to your your project here. And I can bootstrap it with just some content. Okay? And I can carry off just about everything here. I'm going to say, well, in Scaffold, what it's going to do is to automatically detect changes in your source code. When you modify something, it's going to do the recompilation, rebuild your application for you, and then deploy to Kubernetes in this continuous loop. Okay? So I'm going to go ahead and just make sure I have the name of the image here correctly, Jeep demo. And then with the, sorry. Yep, there we go. And with Scaffold, I can also just add what we call the Jeep Maven plugin here. Okay? And as you can see, down here, we actually automatically detected that we added the Scaffold file, and we can actually configure the application to run with Scaffold in Kubernetes just like that. Now, the reason why this is happening is because we have this new tool called the Cloud Code. Right? So this is a plugin you can add to IntelliJ or VS Code, and by doing this, you can actually integrate fully with Scaffold, and also we have other capabilities like being able to deploy this app to App Engine and many other places as well. Okay? So let's go ahead and just finish up this configuration. I think I can also add arcs. Because of the time, I'm going to skip tests. Don't do this in your own development environment. Maybe you do, but I only do this for demos, right? Only, yeah, of course. So I'm going to go ahead and run this. What's that? So I'm going to go ahead and run the scaffold thing through the IDE. So it's going to go ahead and hook up to my Maven here, right? And it's going to rebuild my app and then kick off the zip build for me. And then it's going to automatically deploy my YAML file from the KAS directory. OK? Let me check on time. I got 20 minutes. Yeah, so it's doing the build. Now, the beauty of zip is that it should only change, upload layers that's been changed. So if I haven't done a lot of changes, this whole process should be really quick. Okay? So I have deployed, I created my container, and this is actually deployed into my Kubernetes environment. And the log that you're seeing right now is actually coming from Kubernetes. Okay? This is actually running Kubernetes right now. It's just the log is being streamed into my console. And I can show you what that looks like. So for example, if I go to qctl get pods, we should be able to see that my application is running. OK, that's good. That's a good news. I didn't expect that. Yeah. So then what we can do is to push the I'm going to expose an endpoint so that we can actually access it, just so we know that this is all working. So I'm going to do the same trick here. I'm going to do expose. I'm going to expose the deployment called demo service. The port that we're going to target is port 8080. We're going to listen on the port 8080 as well. I'm going to do a dry run and output the YAML file. I'm going to output it into KAS service.yaml. Okay? Now, scaffold will ideally, I'm pretty sure it will actually pick this up, yeah, and then redeploy this file for me. So anytime you make some changes in your source tree, scaffold loop will pick up the new changes and push it to Kubernetes. And because of this, we should actually have a new service now that's being provisioned called demo service. One thing I forgot to do is to make this an external service so that we actually get an IP. So let me go ahead and fix that, right? So let me go down here. And for the load balancer, for the type, where's the type? Let me do the type here. Type. I'm going to say, type is a load balancer. Let's do that. And that will get us the external IP address so we can actually test it out. Okay? So what have we done so far? We created a brand new application. We containerized it, understanding what JVM version to use. We added liveness check and readiness check. We added graceful shutdown. And we're now changing things now with scaffold so that we can test this thing out in Kubernetes hopefully very quickly. Okay? And now we have added a load balancer with the external IP. So I'm just going to wait for this IP to become available. Then we should be able to see this whole thing in Kubernetes. Okay? Not too bad so far, right? It's OK? Yeah? All right. So the next part of this is to actually add the deployment, modify it so that we take advantage of the liveness checks and the readiness checks. And a few things that we have to watch out for when you want to do a zero downtime deployment. Okay. So first thing first is the liveness probe. We already have this on port 8080, right? And we can also ping it on the path of /alive, right? That's where we put it. And then we have the readiness probe that is also right now on port 8080. And the path is actually actuator/health. Okay. Now, one of the annoying things that you have to be careful of is that remember we added tracing. So I'm tracing at 100%. So what that means is every time I get a health check, I'm going to see a little dot on my trace list for the liveness check. And that's sometimes not so useful, right? So we can actually turn it off in the liveness probe as well. The way we're going to do it is by adding the HTTP header. Now, because we're using Sleuth behind the scenes, it uses what we call the XB3 headers. So we can use the XB3 header called XB3 sampled. And we can turn this value to 0. Then you will not get any more traces for this endpoint that's coming from the liveness probe. This is actually really useful. Otherwise, you're going to see a lot of traces such as liveness probe, which may not help you a lot at all, right? So I'm going to go ahead and save this. And again, this is going to kick off the new deployment. There you go. And it's going to apply my changes and so on and so forth. So yeah, hopefully that's all working. So let's see if the IP came back on. So there it is. So there's 35.22, whatever. And I'm going to go ahead and try it out. See if that works. Oh, OK, not bad. Yeah. OK, so we can also see the actuator right now, which is in health. And oh, look, this is actually down. This is cool, right? Because we have the readiness probe that we configured. Remember, I changed the deployment file, so it's actually doing a rolling update. So as it's doing the rolling update, it sends a SIG term signal to my existing instance. And so now my readiness probe is being turned down. Okay? And Kubernetes does take a couple of seconds to catch up to this status. So that's why the things is still going through. But eventually, this thing will go out of service. And then now I'm back to the new instance of my app with the new configuration. Okay? Pretty awesome. Now, all at the same time, we still have the log messages and everything else that's here. Now, of course, in Kubernetes, when you deploy something into Kubernetes, one of the things you really have to watch out for, regardless of whether it's Run or App Engine or Kubernetes, please do not write logs to the file system. Just please don't do that. You either do std out or you write it to the API. And in GKE, what you can do is to output the log as JSON format. So rather than sending it via the API, you can actually do something like this. So I'm going to go ahead and change this. I'm going to use JSON logging instead, log JSON. So by changing out the appender, we are now able to log things into JSON messages. And Stackdriver has the agent that can automatically parse it, and you get the same benefits of getting the log levels and the trace IDs and span IDs and everything else. Okay? And as you can see, every time I do something, it's going to try to rebuild my app. If you had tests, it will run the test, and we'll redeploy this whole thing. Okay? Now, the last bit of this is that I really want to also add monitoring to this, right? I want to be able to see how many requests is coming through, how long did the request take, and the most important thing in the JVM is how much memory I'm using in the heap, and also potentially how many threads am I running. There are many ways for you to get this. If you have Prometheus, you can use a Prometheus agent. Because I'm in Spring, what I'm going to do is to use what we call the micrometer, which is another open source library that's out there. So by adding micrometer like this with the Prometheus adapter, in conjunction with the actuator, what this will do is to potentially expose your metrics onto an endpoint called /actuator/Prometheus. And if you actually have this configured, then we can actually scrape the Prometheus metrics and automatically forward that to Stackdriver monitoring as well. And we can actually graph and plot out all of these different metrics for you. Okay? So this is what I'm going to do. I'm going to go ahead and just make sure that we have the management exposure. Yeah, there we go. So we want to expose the health endpoint and the Prometheus output here. However, when you do this, you got to be careful, because now anybody who has access to that load balancer can actually hit these endpoints, right? So you're going to see the health, whether your application is up or not. You're going to see your Prometheus stats and stuff like that. So you got to take care of securing those URLs. You can do that within the framework. You can do that via a proxy of some sort. Or this is what I'm going to do instead. I'm going to go ahead and put my actuator, like this metadata information, I'm going to put it on a separate port. I'm going to put it on port 8081 instead. Okay? So I'm still serving my application via port 8080. My liveness check is still on that port. But then my readiness check, my Prometheus information, that's all going to be on the internal port 8081 instead. Okay? So we can definitely do that right there. Okay? So let me go ahead and do that. And then, of course, I have to go back in here and change out the readiness probe to 8081. If I want to use Prometheus to scrape my application's monitoring metrics, there are a number of ways for you to do it. Mostly, you probably install a Prometheus operator. In my case, I just install a bare minimum version of Prometheus. And then we added the Stackdriver sidecar to it so that we can automatically forward the monitoring metrics to Stackdriver trace. And for that to happen, I do need to add a few more annotations here. So I'm going to add an annotation. And to tell Prometheus to actually scrape my endpoints, I'm going to say prometheus.io annotation scrape is equal to true. Okay? And I'm going to do the similar thing here. We need to know which port to scrape. So it's going to be 8081, because that's where the endpoint is. And then finally, I'm going to do prometheus.io path, which is going to be actuator/path. Oh, sorry, not that one, like that. Okay? So again, I'm doing this in the scaffold development loop. Right? It's going to detect the change in my deployment. It's going to go ahead and redeploy. And now with the annotation with Prometheus scraping and all that, right? We can see how this whole thing kind of ties up end to end. And once my application comes back up, I should still be able to access my app, right? And then we should be able to go ahead and go to the monitoring console to see what's actually there. Okay? So let's give it a try. Oh, not like that. So here we go. So here's the endpoint with the persons. I'm going to go ahead and say hello to O again. So I'm going to say hello O, right? And it's going to go through this thing with saying hello to 3 people or so. I can go back to my trace. I'm going to turn on auto reload. And ideally, I should be able to see the, I can see my traces. Now this is actually happening from Kubernetes cluster with the logs output as JSON and correlated to my trace. So everything works as expected in my Kubernetes environment. Okay? And for monitoring, what I can do is then go to static driver monitoring because I have the Prometheus all set up. I can go to static driver monitoring, and I can hopefully use my metrics explorer, and I should be able to find the metrics I want to see. Okay? So here we can go to resources. We can go ahead and, there we go, to go to the metrics explorer. And I should be able to see Kubernetes container. Yep, that one. And then all of these scraped metrics is going to go into a metric called external Prometheus, yeah. And then the suffix of the actual metrics itself. So for example, if I want to see the server request, so I can see request counts. Where is it? Right there. And we can plot this out from my application. And I can also group by, of course, by the name of the pod. Okay. And as you can see, I already have some other application running here. You can see the metrics from it because the agent is running right now, which needs some time for it to catch up, right? The other thing that's also very useful is the JVM metrics. So I'm going to say JVM memory, and we can see memory used in that one. That one's super useful. Okay. And let me go ahead and group by this by the name of the pod and by name of the container as well. Now you can really see that this is definitely a Java application. Right? But why? 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 Because the heap is going to up, and then there's garbage collection, and then you go up again, right? But the good news here is obviously that there's no memory leaks, right? Because otherwise you'll see this thing going up all the time, and then eventually get OOM killed, right? So that's basically what you can get from this whole thing. Now the last thing I want to show you, which is really, really awesome, is by adding some debugging agents into your application. Now, what happens if you are in a pinch, really, really need to figure out what happened to your app, why is it not working, like what it is that we don't run. You cannot reproduce the issue locally. You need to figure this out, right? So we can actually go ahead and add the debugging agents into this whole thing. Now we can go back to the project. This is where I'm going to go. I'm going to go to source. And I'm going to create a new directory here called gib and agents. Okay, so anything you put into gib will get into the container. I'm going to go ahead and copy my agents from, let me see, where did I put it? Desktop. No, not that one. Downloads. Yeah, agents. So I have a few agents here I can copy into my directory. Right. So now I have, when I build in my container, I got these debugging agents I can rely on that can hook me up to static driver debugging, even from a Kubernetes environment. Okay. But I do need to make sure that when the application is starting up, I do have the right startup flags to actually utilize the agents that we just added. Right, so here, I'm going to add some JVM flags, which will configure the agents for me. So I added 2 agents here. I have a debugging agent, so I can live debug my application live without stopping the world. And I also added a profiler agent, so I can do production profiling, so I can kind of figure out where the slowness is kind of happening, right? So let me go ahead and save this. And of course, scaffold is going to kick in again, and it's going to rebuild this application with hopefully the debugging agents, with the entry point, with the agent arguments that I passed in, right? This is all very quick that you can see how this whole tool set kind of tie up. And then deploying it into into Kubernetes cluster. Oh my goodness, yeah. And we can see that at the startup, we can see the agent actually kicked in. So here's the output from the agent. And hopefully my application starts up fairly quickly. Yeah, so it's all ready to be used, I hope. And then let's go and see what we can do. Okay. So I'm going to say, let me just make sure I have this thing all hooked up. So I'm going to go to persons/persons. Yeah, everything is still working. Good. We only have 5 minutes left. That's why I keep this to the last, right? If it doesn't work, then thanks for being here. All right, so so what we can do then is this is so cool. This is so cool. If you've ever seen this before, this is so cool. So I'm going to go back to my console here. I'm going to go to debug. So we saw trace, we saw logging. I'll tell you what, I'm going to go to profiler. So because I added the profiling agent there, I can see my service called demo service, which is the one I created. I can see the version, which is the one I put into the startup command line. And I can see the actual flame graph of how much time, CPU time, my application is consuming at different stages, right? So I can click into it. I can see the flame chart underneath it. So this is a really nice way to kind of figure out where all this time is being spent. But here's the other thing that you can do, which is debug. This is super cool. If you have your code checking to Git, if you're using the Git plugins, we can actually automatically check out the code for you, and we can automatically find the source code, okay? But in my case, because I don't have the source code uploaded, what that means is that I need to somehow wait for this UI to come back up, in which case I should be able to see my service that's listed here. Oh, thank goodness, it still works. All right. So somehow over here, after some runtime, I should be able to see my application that I just deployed. I don't see it yet. So we'll need to wait a little bit for it to come back up, right? So let me just make sure my app is still there. Yeah, OK, good. Yeah. So eventually, this will come in. And what I can do is to browse through this UI, hopefully find the application I'm trying to debug. And then from there, I can actually just start adding these snapshot points. Then I can capture the state of my application as the lines going through the code. And I don't know if this ever happened to you, when you're trying to debug something and you see the log messages, and then you say, oh no, I wish I have one more log. What do? You got to go back, check out the log, check out the application, check out the right revision of the app, and then what? And then check it back in, go through the hot redeployment of some sort, bypass a lot of processes and stuff like that. I don't know. It's trying to get to production so you can actually get that log message. With the debugging agent, you can actually do that directly from the console, provided that you do have the right access to do that. So let me see if this actually came back. Hopefully it's there. Oh, there it is. All right. So now you can see that my application registers itself with the debugging console here. So we can see demo service with the version 0.0.1. I have no source code, so I can go ahead and upload it if I want to. I can also do this from the IDE as well if I want to. But right now, I'm just going to go ahead and upload my source code in the Kotlin. So this actually works with Java and Kotlin code right now as well. Okay. And I'm going to go back to this place right here. I can see my source code. All right. And I can add a snapshot point anywhere. So I can say, I wonder what's happening here. Again, provided you have the right permission to do it. You can say, I wonder what is happening on this line of code. And then if I come back here, and if I say hello, now watch very carefully. I'm going to say name is Ray again, I guess. Ray. Watch carefully on the right-hand side, hopefully. Oh, well, somebody hit it first. Great talk. Thank you. That's awesome. In case you don't want those messages, well, I love this message, but in case you don't want to capture everything, you can also add conditions here, right? So you can, based on the condition of what you want to capture. But thank you very much for whoever that sent this first thing in. So you can see the values. You can also see the code stack. But so here's the thing. Here's my favorite part of this whole thing, which is the logging part, right? And somebody told me about this. It's called binary debugging with logs. What does that mean? This is what we usually do, right? We add a log message at first, at the beginning, say, I'm here. And then you add a message at the very end to say, it works. If it doesn't get to it works, that means it works somewhere in the middle. Then you add a message in the middle somewhere. Maybe it broke here, right? And every time you do this, we actually output the log for you into the log messages. We should be able to see it in the log here. So if I do another refresh, and when the logs come through, we should be able to see this being produced directly in your production environment if you have the right process and permission to do it. Okay? So with all I said, I think we did a lot in the past 15 minutes. Hopefully it was very useful for you as well to kind of get a feel of what it is like to develop applications on Google Cloud with framework support, with all the toolings that we have in the IDE, in the plugins, and with other things like Scaffold and Jib. If you want to learn more, this is the last slide I'm going to get to, which is we have quite a few resources you can go to. You can try a lot of things which I just show you in the long collab. If you want to learn more about Spring and Spring Cloud GCP, you can go to our short collabs there. We also have Coursera courses. We got great documentation. And if you want to get in contact with me, you can find me on Twitter or come to my site and find more information. So thank you so much for being here. I really appreciate it. Thank you.